about Git and GitHub. So before we dive into Git or GitHub, we first need to understand what is the need of undo in software development, right? So I'm talking about the development life cycle over here, right? So why and like where do we need to do undo in the software development life cycle? So let's understand this process. So let's say as a developer, I have generated a build, right? I have implemented a functionality and generated a build, and that build I have tested that build, and which is actually working fine. So what I've done, I have actually send it to the deployment server, and I have deployed it over there, right? Now let's say in an agile environment or in any life cycle, if there are any changes in the requirement, if there are any changes in the requirement which been like suggested by the client, right, that needs to be implemented in the current project. So what as a developer I will be doing, I'll be implementing that change in the current build, and I'll generate another version of build that is build 2, right? So again I'll test that build, and again the process for deployment will gonna remain the same, right? So that build will be deployed again onto the deployment server, right? Now let's say during deployment of the build got broken, and the changes that I wanted to be implemented in this build was not actually implemented over there, right? Now the build is completely broken. Now what I want, that I want to revert back to the previous build. So I want to actually do the I actually want to do undo the changes, right? I actually want to undo the changes that I have committed in the current build. So if I have actually kept the previous build stored on some location, on some archive folder, so I can actually get that build from there. But what if I haven't stored that at any location, and this build got overridden by the new build? Then there will be a reason of worry for me, right? So how will I actually undo the changes that I have made in the current build? Because I mean, due to these changes, the current build got broken, right? So if it is a small software, if it is a small software, then this thing can be very easily managed by managing the build manually, right? Storing it some location and then get it back, right? So let's say there are 100 developers involved in actually implementation of this feature, and this is a huge project, right? This is a very big project. Then the real challenge will come over there when we need to undo any change, right? And this is where your version controlling system comes into the place, right? So it will actually let us know how to revert back to the previous version. There are many version control tools available in the market, right? But in this module we're gonna talk about Git and GitHub, right? So if we talk about version control, revision control, subversion control, all these are one of the same thing. So versioning control is basically a process in which state or version of a software is continuously tracked, right? So this system records each and every changes to a file or set of files that we made, right, during development, so that we can anytime revert back to the previous version or previous state of the code whenever there is a requirement, right? So everything over here is being tracked by the version controlling tool, right? So each and everything, if we make even a single change to our code, then that thing will also be tracked by the version control tool, right? So let's see how many types of version control systems are there available in the market, right? The very basic one is the local version control system. So let's understand first how this local version control works. This is the very simplest one, right? In which programmer copies the files into a timestamp directory. Timestamp directory, as in, let's say there is a very small project and only, let's say, one developer is working on that project, and he want to maintain the versioning of the files which he like write on a daily basis, right? So the code that he write on a daily basis. So how in a very simple way how he gonna do that? So let's say he go to his local repository, he create a new folder for version control. Let's say give it a name as version control, right? Inside it, he'll gonna create some folders. Let's say a folder. Let's say that today the date is let's say 20th, right? So 20th, and he'll gonna maintain whatever code that he'll gonna write. He'll gonna maintain inside this folder for today's date, right? And let's say the next day when he comes, he do whatever work that he do, he'll maintain in another folder with the second date, right? That is 21st of June, right? So same way, if he wants to manage it beyond this as well, then he can implement some time stamping. He can create some other folders. Let's say check in as in like the code that he has implemented at 7 p.m. He'll keep that code over here. Then next code for 8 p.m. he will keep over here, right? So this is how. But this system is completely manual, right? So this system is completely manual. Moreover, it is more successful where only one developer or one programmer or one tester is involved in this project, right? But if we are actually talking about a big project, then this version system, this local version system, will not gonna work over there, right? Because this system is more error prone, and it is actually beneficial for a single programmer. Because if lots of people are involved in the project, and if they are actually trying to manage this sort of system, so that is not feasible, right? Now there is what we find a need of centralized version control system, right? Now, in centralized version control system, we have a centralized repository, right, which is kept at one location. And let's say our developers are like sitting at different locations at different time zones. Let's say one is sitting in New York and one is sitting in Seattle, right? So let's say developer A checks in the code, right? He whatever coding that he has done for the day, he pushed that code onto the centralized repository. At the same time, the developer B, who is at a different location, can actually pull that code from that centralized repository at the same time. And again, he can do some changes, and again he can commit that changes. He can push that changes to that centralized repository, and then developer A, if he wants to like check out all the changes that he has actually committed, if he wants to pull all the changes, then he can do at his own end. Same way, other developers who are sitting at different location can easily push and pull the code from the centralized repository, right? So here the challenge that were faced in a manual local version control system has been actually resolved by the centralized version control system, right? So the client which are actually connected to it can push or fetch any product version by remote access, right? Which means that the process through which files are pushed in this case in the repository are called as checked in. So you might have heard about the term check-in a lot of time, right? So check-in means that when we are actually like pushing our code from the local machine, from our desktop or laptops to the centralized repository. It could be SVN, it could be VSS. There are many centralized version controlling systems available in the market, right? So, and the process of fetching the data, fetching the code from the centralized repository is actually called as checkout, right? So these are the two most important terms that are being used while working on the centralized version control system. That either you can check in your code or you can check out the code from the centralized repository, right? Now, there are some limitations as well that are there with the centralized version control system, or you can say there are a few major drawbacks with the centralized version control system, and that is, let's say, if all the files are stored on a centralized repository, right, and if somehow the server is down for any period of time, right? So no programmer or no developer should be able to perform check-in and check-out, right? So it will be a downtime for them. They should not be able to perform any check-ins or any check-out, right? So you can yourself analyze that the time of amount that will be wasted in that particular period, right? The other situation is that let's say a hard disk for that centralized server gets corrupt. Now the entire history of the project will be gone and will lose everything, right? If they don't have any backup stored on any other server, then the entire history will be gone. So due to these problem and these situations, there is another thing that is being invented and overcome the challenges of the centralized version control system, and that is through distributed version control system, and that is where the Git and GitHub comes into the picture. So now in distributed version control system, whenever a client machine fetch out the latest file from centralized repository, it actually fully mirrors the whole project into that the whole project repository. It actually mirrors the whole project repository onto their local machine. Let's say you can see these two images over here. One is the traditional one and one is the distributed one, right? In traditional, what happens, let's say all these client machines are connected. They are actually checking in and checking out code from this repository, and this repository is connected to this server, right? Now let's say if this server is down, then all of these guys will not be able to connect to this repository and should not be able to check in and check out code from this particular repository, right? Now if we talk about distributed version control system, so let's say if we talk about, let's say this is a centralized repository, right? So whenever let's say any client checks out the code from this repository, so what this will gonna do, this will actually gonna bring the entire repository as a mirror onto their local machine. Same way, if the second client, if the third client will perform the same thing, then the entire repository will be checked out. Will be checked out to its to his local machine as a mirror, right? So each system will gonna have a backup of all of entire repository code and files that are maintained via distributed version control system, right? So in this case, each client machine is a complete backup of the project, actually, right? So if centralized repository fails, any client repository can be copied to the server in order to restore the entire project, right? And in this, every checkout is a full backup of that project, and this is where the Git comes into the picture. So the other thing, I mean, a major advantage of using distributed version control system is that, let's say you are onto the centralized like version control system. Let's say you are using SVN or VSS, right? So in that case, you need to be connected to internet all the time to perform check-ins and checkouts, right? And somehow, if you're not connected to internet, then you are not able to perform your work. You're not able to perform any check-in or check-out. But in case of this distributed version control system, in case of Git, you need not to connect to the internet all the time, because the entire repository is available on your local machine itself as a mirror, and you can perform all the commits, check in and check out to the local repository itself. And when you are connected to the internet, you can push the entire repository to the distributed environment, right? This is how your Git and GitHub will gonna work, right? So let's talk about Git over here. So when I'm saying Git, I'm just talking about Git. I'm not talking about GitHub over here, right? Git and GitHub, these two are two different parts, right? So Git is basically a software that will be installed on your local machine. And GitHub is that centralized repository where you will be pushing your entire project code, right? That is a centralized server where you will be performing where you'll be keeping the versioning control of your current project, right? So if we are talking about Git is basically a distributed version control system in which all files of a particular project is stored in a centralized Git server. So centralized Git server is what GitHub is, right? So it's a tool which manages the source code history. That is what the major task of Git is. It will actually going to track whatever changes that you made in your current project, or whatever new things that you're going to implement in your current project. It will actually going to track all the changes, right? So if you actually made just two if you actually add two lines of statement in your current project code, then that as well will be tracked by Git software itself, right? So the working of Git is completely different from how other centralized version control system works, like SVN or VSS, right? So in Git, whenever a client checked out the files, the whole project is copied onto the client machine in a hidden folder, right, and in a compressed form. So the entire replica, entire mirror of the project is actually stored on the local client machine itself, right? If you specifically talk about Git and GitHub, there are many open source projects which are actually using this Git, right? Let's say if you go to the Selendroid or Selenium projects itself. Let's say if I go to Selendroid .io, you can see fork me on Git. So their entire project code is on GitHub. They are actually maintaining their all the version controlling onto this GitHub project, right? Same way, there's one iOS driver, and this is again on GitHub, right? Even okay, this does not shows up. So if you write iOS driver website, and this is the main homepage of their website, right? Again, this is maintained on GitHub itself, right? Even the entire Selenium project, the WebDriver project, you're gonna find the entire code of the WebDriver project on GitHub as well, right? So many open source projects actually use Git and GitHub, because this is the best version best distributed version control system available in the market, right? So in the next lecture, we're gonna see how we actually gonna install the Git on Windows, right? So that's about it in this module, and we'll meet in next module. All right.